These problems that involve solubility and the KSP are really like we've been doing with the equilibrium constants and equilibrium concentrations. The KSP is basically like we've been treating the KC, and the equilibrium concentration is the solubility. So let me just write what that is. Okay, and I wrote the little approximation because you need to make sure that's in molarity when you start using it. So that's one thing that you will do, is you'll use the molar mass to convert that to a molarity. In fact, let's just do that before we start doing all the other stuff. So we're going to use the molar mass of silver chromate, which is 3,3. Just so we don't forget later, we'll get this ready. And you can tell from that number it is that's equilibrium concentration, a very small number, which is what you expect with these, because KSPs for salts are only if they're not very soluble. So just to review how this is going to work, our equilibrium constant and our equilibrium concentrations, which this is our solubility. Those are related by using a Rice table. And the values, the algebraic expression for KSP with the X. So let's start with our Rice table. For the reaction, you're always going to just use the solid dissolving. So the solid is the silver chromate. And it's just breaking apart into ions. We need to watch our coefficients here, because we're going to use those coefficients to get our algebraic expression and so forth. So this had 2 silver ions, so I need a 2 there. 1 chromate, 1 chromate. And technically should show a charge. Okay, so that is our reaction. The next part is the initial. And this is where you need to know what to assume. What you do is you assume that at the beginning, we always say initial, we just have solid and it's not in water yet. So I'm just going to write solid here and 0 for these because nothing has dissolved yet. Okay, for our change, I'm going to say we're going to lose X of this, the solid, as it dissolves. And so for this, I will get plus 2x, and for this, I'll get plus x. Now, why? First of all, let's talk about this x. This is x we use as the amount dissolved. And it's always the amount of the solid that dissolves, okay? And it's x moles. This number here is always going to be a 1, so it'll always be minus 1x. When you come over here, this is a 2 because of this 2 here. Every one of the silver chromates that dissolves produces 2 silver ions. Okay, and this again is a 1 because there's a 1 here. So on this step, we always look at the coefficients, we always have. And then what's happening at equilibrium we're going to have the solid, and we tend to abbreviate that just SOL, solid minus x, and here I'll just have 2x, and here I'll have x. Remember, what I'm doing for those two, this step, is I'm just adding these two to give me that. Okay, once we get this the algebraic expressions for the equilibrium concentrations, we can make an algebraic expression for our equilibrium constant. So our equilibrium constant is KSB, and we are going to get this, I'm going to go back to the original reaction. We would expect it to be, remember this is always products over reactants, so I'm going to expect it to be silver times chromate except remember that when you do these expressions you use that coefficient there as well. So this too, it kind of gets used two places. It got used there, but it also, in these equilibrium constant, it gives you exponents. Okay, and then normally I would divide by the concentration of the reactant. But the reactant is a solid, and we never include solids in our equilibrium constants. Okay, so that's why it's the solubility product. That's all there is to it. So I can plug in my x's now. Okay, and then I might say, wow, it would be great if I had numbers for x. I could get my KSP, my solubility product for this salt. But you know what, I have it. We solve for it up here. So let's look up here. This value, the solubility in terms of molarity, this is x. So solubility in molarity is the same thing as x. Let me write that down here so we'll have it. Okay, and that will always be true on these. If you set up your reaction, if you set up your rice table like we did, we always just have a minus x there. And so this, it's the amount that dissolves. It's the solubility, if you want to add that there. Make sure we have all our words straight. Okay, so I can plug in that x here, that number. Okay, and there's the value we were looking for, our solubility product. Remember, it is unitless, just like any other equilibrium constant. And I did base my sig figs based on my original solubility 2 sig figs.